Now let's use some real-world elasticity coefficients to understand these determinants more. Take a look at books. If Barnes & Nobles is selling books, they have a very responsive consumer, elasticity of 4, whereas Amazon, selling presumably the same books, has a much less responsive consumer, elasticity coefficient of 0.6. This difference could be in part explained by there being more substitutes for Barnes & Nobles than there are for Amazon. Take a look at Raisin Bran here. Notice we have a specific brand and we have a high elasticity. That might be because we're defining the category in a narrow fashion. If I were to get rid of the post and just say Raisin Bran, we would expect this elasticity coefficient to go down because we'd be defining the category more broadly. There's a lot more substitutes for post Raisin Bran than there are for the category of Raisin Bran. Similarly, if we have a broad category here like automobiles and an elasticity coefficient of 1.95, if I said Ford automobiles, this coefficient would likely go up because we would be defining the market in a narrower fashion. Also note that inexpensive goods, such as sugar or milk, have very low elasticity coefficients. That's probably because they make up such a small proportion of the consumer's budget. So the price of sugar could double and people continue to buy sugar. You'll also notice that beer, cigarettes, and oddly enough, cocaine, you would see these elasticities very low as well. And this is likely because in the eyes of the users, it's an addictive substance, and therefore it becomes a necessity with less close substitutes. All right, let's go ahead now and talk about the elasticity along a linear demand curve. Recall before that we saw the elasticity varies based on the steepness or the flatness of the demand curve. Steeper curve, more inelastic; flatter curve, more elastic. But elasticity also varies at different points on the curve. For example, starting at a price of $80, if we lower the price to 76, there's more demand. It goes from 10 to 12. If you calculate the elasticity in this range, you'll get 3.6. You can see the calculations down here. Between point R and S, we can find the percentage change in price by taking the $4 change and dividing it by the midpoint, which is 78. That gives us a percentage change of 5% in price. The quantity percentage change would be that 2 units divided by the midpoint of 11. That gives us an 18% change in quantity. 18% change in quantity divided by 5% change in price gives you an elasticity of 3.6. Notice, though, that if instead of going from 80 to 76, we go from 50 to 46, which is a $4 decrease, just like 80 to 76, we see an increase of 2 units from 25 to 27, just like we saw an increase of 2 units before. So in terms of the slope, it's the same value. $4 decrease in price leads to 2 unit increase in quantity. But we're not calculating slope. We're calculating elasticity. And when you do these percentages, you'll find between these two points here, you have an elasticity of 1. Much less elastic than up here. And then it continues. If you go between these 2 points, you get an elasticity of 0.2. So changing the price by $4 from 80 has a more responsive consumer than changing the price by $4 from 50, which has a more responsive consumer than changing the price by $4 from 20. Why is this? It's because One of the determinants of elasticity of demand is the proportion of the consumer's budget. At higher prices, the good makes up a larger proportion of the consumer's budget. So you get a more responsive consumer, a higher elasticity coefficient. But as the price goes down, you see a less responsive consumer, a less elastic coefficient. Now we can summarize and recognize that the availability of close substitutes, that is reflected in the steepness of the curve. With a steeper curve, more inelastic, less substitutes, and a flatter curve, more elastic, and more substitutes. But we also know now that the share of a good in a consumer's budget, that is reflected at different points on the curve, with a higher price good being more elastic and a lower price good being more inelastic. Now let's take a look at total revenue and the price elasticity of demand. These coefficients that we're analyzing help businesses make better pricing decisions. When a business is making a price decision, whether to raise prices or lower prices, one of their considerations is going to be the effect that that price change has on their total revenue. Total revenue is the total amount of funds received by a seller of a good or service. It's measured by the price of the good times the quantity. Let's take a look at a gasoline market down here. We actually have two gasoline markets. This one over here has a very inelastic demand, as represented by the steep demand curve, and this one has an elastic demand based on the flatter curve. From our previous lesson, this demand curve would have less substitutes in the eyes of the consumers than this one would. Maybe in this environment, the gas station doesn't have any competitors nearby, but in this environment, there's competitors on every corner. Let's start out at $3 and $1,000 in demand. So if you own this gas station, you've chosen that price. But then you consider, what if I lower my price? Well, if you lower your price to $2.70, then your demand is going to go up in quantity from 1,000 to 1,050. So essentially, you're going to lower your price by 30 cents in order to sell 50 more gallons per day. What are the effects of this? Well, we can look at this in total analysis or marginal analysis. Total analysis says, what's my total revenue? Well, at $3, you were selling 1,000 units. So this entire area here would be your total revenue. That's easy to calculate. $3 times 1,000 is $3,000. $3 times 1,000. And then if you lower your price to $2.70, you're now going to sell 1,050. So we can take 270 times 1,050, which would be this entire area here, and you'll get a total revenue of 2,835. If your goal is to maximize total revenue, you wouldn't want to lower your price. You wouldn't want to go from a total revenue of 3,000 to a total revenue of 2,835. If we look at this from a marginal standpoint, you would be lowering your price from $3 to $2.70 on the first 1,000 units. That means you would take a 30-cent hit on 1,000 units, which means you would give up $300 in revenue. But then you would sell 50 more units at $2.70. So you would gain $135 in revenue. Probably wouldn't want to give up $300 in revenue to get $135. So it gives us the same outcome. We don't want to lower our price if our demand is inelastic. Contrast that with the scenario over here, where you have a more responsive consumer because there's more substitutes. If you lower your price from $3 to $2.70, then you're still going to give up the $300 on the first 1,000 units. But you're going to sell a lot more units because you have a responsive consumer. It's elastic. In fact, you're going to sell 200 more units. At $2.70, that's $540. It would be more prudent to give up $300 in total revenue to get $540. This reminds us that when we face an inelastic demand curve, lowering our price would lower total revenue. But if we face an elastic demand curve, lowering our price would raise total revenue. The reverse is true as well. And you can look at this by starting at $2.70 in each of the models and then raising the price to $3. In the inelastic environment, that would cause your total revenue to increase. You'd give up $135 but get $300. Whereas in the elastic scenario, you would have your total revenue decrease because you would give up $540 to get $300. We just learned how elasticity varies based on the steepness or the flatness of the demand curve and how that influences total revenue. Now we're going to consider how elasticity varies along a linear demand curve and how that influences total revenue. To do this, let's take a look at the market for DVDs. And we can do this graphically, but we also have a table here that lays out the demand schedule from which these points were plotted. We're going to construct a total revenue model directly below our demand model. Notice that the horizontal axis here is the same as here, both quantities of DVDs per month. But down here, we're going to have the vertical axis as total revenue rather than price. To understand this, let's imagine we start our business by pricing the product at $8 a DVD. But we're going to sell 0 DVDs. So what would be our total revenue at 0 DVDs? It would be 0. If, however, we lower the price to $7, then it looks like we will sell 2 DVDs. Therefore, our total revenue at 2 DVDs will be 2 times 7, which will be $14 in total revenue. If we lower the price again to 6, we will sell 4 DVDs. Therefore, at 4 DVDs, our total revenue will be 4 times 6, which is 24. You can continue doing this. And what you'll find is as you continue to lower the price and sell more DVDs, your total revenue is going to go up and up. It's going to peak and then it's going to go down and down. Eventually, you're selling 16 DVDs, but you price them at 0, and so your total revenue is 0. So we get this bell-shaped total revenue curve. This is explained by the different elasticities along the curve. Notice when the price was high and made up a large proportion of the consumer's budget, we had an elastic consumer. So when you lowered the price, you actually got an increase in total revenue. But once the price got lower and lower, you started to face an inelastic consumer because that price made up a smaller fraction of their budget. And you started to see further decreases in price, lower total revenue. The effects are summarized here in the table. When we lowered the price and we had an elastic demand, total revenue increased. That was this phase here. But then when we lowered the price and we had an inelastic demand, total revenue decreased. That was this phase here. You can reverse this. What if instead of starting at $8 and going down to 0, we start at 0 and move up to 8? Well, as you do that, as you raise the price, you're in the inelastic phase of the demand curve. Well, we know from before that if you raise your price and you have an inelastic demand, you're going to increase total revenue. And that's what's happening here. You're increasing your price, selling less, but your total revenue is going up because you have an inelastic consumer. As you continue to raise your price and sell less units, you're facing the elastic portion of the demand curve. And your total revenue is starting to decrease until eventually you get to an $8 price and no sales. Now we know the answer to this question is false. Firms may actually lower their price to increase revenue if they face an elastic demand.